Alright, so before I want to explain another chemical properties of haloalkane, I would like to do some recap on the nucleophilic substitution of haloalkane. So, if let's say this is haloalkane and kita buat proses hydrolysis of haloalkane by using a weak nucleophile such as H2O ataupun strong nucleophile such as NaOH ataupun KOH yang akan result in the strong nucleophile OH minus, and I will get an alcohol. Okay, but then if we do alcoholysis for haloalkane by using a weak nucleophile such as alcohol ataupun strong nucleophile such as sodium alkoxide ataupun RO minus, we will get an ether. Alright, but then if kita reactkan haloalkane dengan carboxylic ion such as RC double bond O minus ataupun pada asalnya RC double bond O Na ataupun K, we will get an ester. And then if we react haloalkane with ammonia, we will get a primary amine. And if we react haloalkane with cyanide dengan strong nucleophile such as Cn minus, we will get a nitrile compound. Nitrile compound, dia ada dua further reactions yang dia boleh buat. The first one is hydrolysis with H2OH plus dengan reflux, which will result in the formation of carboxylic acid. Okay. And then kalau buat reduction of the nitrile compound by using reducing reagent, we will get a primary amine. Alright, so the next chemical properties of haloalkane is the elimination reaction of haloalkane, which is the name of the reaction is dehydrohalogenation of haloalkane, and we will remove halogen and hydrogen at the neighbor carbon. Okay, so this is the general formula. I believe that you have met this bila you nak prepare alkene, right? Where we use haloalkane as the reactant, and then the reagent that we use is ethanol, sodium hydroxide, and also the condition is reflux, and lastly we will get alkene as the product. And the major product must follow Zev's rule. Zev's rule cakap apa? Ingat lagi tak Zev's rule cakap apa? Zev's rule states that bila kita nak form the major product, it must be the most stable alkene, which alkene tu dia kena highly substituted alkene. Okay, for example, this is a primary alkene and ada dua sahaja carbon. So dia tak ada pressure pun untuk buat major dengan minor product, because we will remove Cl from this carbon and one of the hydrogen from this carbon. So we will form this kind of alkene. And the next one, this one ada major dengan minor product, because if you look at this carbon yang kita akan remove the Br, okay, dia ada choice untuk dia remove hydrogen from neighbor kat belah kanan dengan neighbor kat belah kiri. Okay, so dia ada dua choice. So kalau let's say dia remove dekat neighbor belah kanan, okay, dia remove hydrogen dekat neighbor belah kanan, this hydrogen is a primary hydrogen because this is a primary carbon. Therefore, kalau let's say I remove hydrogen from this carbon, it will form the minor product. But then if you look at the neighbor belah kiri, okay, kalau tengok dekat neighbor belah kiri, this carbon is actually a tertiary carbon. So it will make this hydrogen tertiary hydrogen. Therefore, if I remove this hydrogen from belah kiri ni, I will get the major product. Alright, so the last chemical properties of haloalkane is the synthesis of Grignard reagent. This is how Grignard reagent looks like, where R ialah alkyl, Mg magnesium, X halogen. Okay, this is how Grignard reagent looks like. So basically it's an organometallic compound of magnesium, and the bond between carbon, R ni alkyl kan, alkyl always starts with carbon. So the bond between carbon and magnesium ni is actually highly polar bond. Therefore, it will be a highly reactive compound and it can act as nucleophile. So, apa kegunaan Grignard reagent ni? Kenapa kita nak kena hasilkan Grignard reagent? Because from Grignard reagent, we can form an alkane. Kita boleh form alcohol, and also we can form carboxylic acid. How to prepare Grignard reagent? We can prepare Grignard reagent if we have reactant haloalkane, and then the reagent must be magnesium in dry ether. So the product yang kita akan hasilkan ialah Grignard reagent. For example, if this is your haloalkane and kita reactkan dia dengan magnesium in dry ether, basically kita akan hanya substitute saja. Kita masukkan magnesium ni dekat sebelah Cl. Okay. Therefore nanti you punya produk, you just letak magnesium tu dekat sebelah halogen je, and you will get this. This is what we call as Grignard reagent. Okay, so let's try this out. If let's say you ada this kind of haloalkane and then you react dengan reagent magnesium in dry ether, because why? Because you want to form a Grignard reagent. So macam mana rupa Grignard reagent yang terhasil tu? This is how it looks like. Okay, you just letak magnesium dekat sebelah halogen. Kiranya magnesium ni di antara alkyl and also halogen. That's how you should draw it. Okay, next, if let's say this is your Grignard reagent, how is your haloalkane looks like? Macam mana you punya bentuk haloalkane tu? Haloalkane tu kena alkyl dengan halogen. Therefore, this is the haloalkane that form this kind of Grignard reagent. Okay, basically you just remove the magnesium to figure out what kind of haloalkane yang form this kind of Grignard reagent. Alright, so from the previous slide, I already told you guys that from Grignard reagent, kita boleh hasilkan alkane, alcohol and carboxylic acid. Kan? Okay, so macam mana kita nak form alkane daripada Grignard reagent? Grignard reagent ni terhasil daripada mana pula? Daripada haloalkane react with magnesium in dry ether. Kan? So, kalau contohnya lah, dalam soalan tanya kamu macam mana kamu nak form alkane daripada haloalkane, so it has to go through Grignard reagent. So daripada haloalkane, you reactkan dengan magnesium in dry ether and then you akan dapat Grignard reagent. So from Grignard reagent, you boleh hasilkan alkane. Macam mana nak hasilkan alkane? You kena guna reagent H2O H+. So what happened here, if you notice at your Grignard reagent, you need to highlightkan the alkyl group in your Grignard reagent. So the carbon that is directly attached to the Mg halogen will accept one hydrogen atom from the H2O. Therefore, terhasillah alkane, and this is a side product yang terhasil. It is not that important as this major product. Okay. So for example, if you have this Grignard reagent, okay, they react dengan H2O dengan H+, because they nak form alkane, right? So first thing first, I want you to recognize the alkyl group here. So this is the alkyl group that is directly attached to the Mg halogen Cl. Okay, because why? Because this alkyl group will accept one hydrogen atom from the H2O. So daripada satu je hydrogen, and then dia akan jadilah dua hydrogen. What happened to the MgCl? The MgCl dia akan dissociate daripada alkyl group ni, and then dia akan jadilah MgOH Cl like this. Okay, so the next one, if this is the Grignard reagent yang you dapat and you buat dengan reagent H2O dengan H+, that means dia nak menghasilkan alkane. Again, you need to identify the alkyl group that is directly attached to the Mg halogen Br. Okay, because why? Because this carbon atom will be the one yang akan accept the hydrogen atom at this H2O. Okay, therefore, daripada satu je hydrogen, now dapatlah dua hydrogen. Okay, so this is the alkene yang terhasil from this Grignard reagent. And this is the side product yang terhasil. Okay, last one. If let's say you ada this alkene, contohnya ditanya, apakah Grignard reagent yang menghasilkan this alkene? Alright, so you tengok ni, this alkene actually, if you look here, this is CH3, right? That means this carbon, they accept hydrogen. So since that this carbon, they accept hydrogen, ni macam hydrogen yang dia baru add. Hasil daripada apa tu H2O kan? Therefore, I believe that before that, the Grignard reagent will look something like, okay, cyclohexane, CH2, lepas tu terus MgBr. Betul tak? Yes, correct. Okay, so kiranya alkene ni terhasil daripada this kind of Grignard reagent. Okay, because this is an alkyl group yang directly attached to the Mg, halogen Br. Therefore, this alkyl group, this carbon akan terima satu hydrogen from this H2O yang menghasilkan this kind of alkene structure and this side product. Okay guys, next is from Grignard reagent we can form alcohol. Alcohol with different classes pula tu, primary alcohol, secondary and tertiary alcohol with respective reagents. Okay, kat sini kan, kenapa you wajib letak 1 dan juga 2 atas arrow ni? It is because it wants to show that Grignard reagent ni memula dia react dengan methanol, lepas tu dia buat hydrolysis. Okay, so that's why you tak boleh tulis contohnya reagent tu methanol, H3O+. Because kalau you buat comma macam ni, it means that dia react dengan methanol lepas tu dengan H3O+ ni sekaligus. We don't want you to do that. So that's why lah you kena letak nombor 1 and then nombor 2 atas arrow. Okay, so kiranya kalau if you want to do a primary alcohol from Grignard reagent ataupun kalau you nak menghasilkan alkohol daripada haloalkane, so you kena menghasilkan Grignard reagent first and then from Grignard reagent you kena react dengan reagent yang pertama methanol, yang kedua dia akan buat hydrolysis H3O+. Okay, and then next if dia nak buat secondary alcohol, the first reagent yang dia akan react is aldehyde except methanol, and the second one dia akan buat hydrolysis. And kalau let's say from Grignard reagent nak menghasilkan tertiary alcohol, therefore the first reagent yang dia akan react ialah ketone and the second one dia akan buat hydrolysis. Okay, macam mana you nak form primary alcohol daripada Grignard reagent? So this is cara yang quite panjang and quite lama because this is singkatan dia actually. Yang ni cara yang panjang dia lah. Kita tahu kalau kita nak form primary alcohol, Grignard reagent tu kena react dengan methanol dahulu. Lepas tu dia buat hydrolysis. Kalau Grignard reagent dia react dengan methanol dulu. Okay, kena ada kehadiran dry ether. Lepas tu nanti kamu akan dapatlah organometallic compound like this. Lepas tu buat hydrolysis baru dapat primary alcohol. Or it can also be written as the following. Okay, where this is your Grignard reagent. And then the first reagent yang you kena react with is methanol. So this is methanol. Second one dia akan buat hydrolysis. And terus akan dapat primary alcohol. Okay, so for example, if you have this kind of Grignard reagent and you reactkan dengan methanol and then you buat further hydrolysis, that means you want to form a primary alcohol. So this is a primary alcohol yang terhasil. How can you get this? Okay, again, this is your Grignard reagent. You need to identify the alkyl group at your Grignard reagent. So this is the alkyl group at the Grignard reagent. So apa yang berlaku? The carbon that is directly attached to the Mg halogen Br akan bercantum dengan CH2O. Okay, kan sebab dia buat hydrolysis. Because dia buat hydrolysis, therefore, this methanol daripada CH2 double bond O ni, dia akan jadi single bond OH. Okay, so that means this is your primary alcohol terhasil daripada CH3 of your Grignard reagent, and also this part CH2OH ni dia terhasil daripada methanol yang dah dihydrolysekan. Okay, can you see that resemblance? I hope that you can see that. Okay, and then this is the side product that kamu akan dapat daripada this kind of reaction. Okay, so next. Okay, contohnya lah. Kalau let's say you ada this kind of Grignard reagent and then dia react dengan apa and then dia akan buat hydrolysis untuk dapat this primary alcohol. How do you know that this is a primary alcohol? This is a primary alcohol because this alcohol, this carbon is actually a primary carbon. Okay, because this carbon is a primary carbon. Since that is a primary carbon, therefore it will be a primary alcohol. Okay, so as what I have discussed or explained to you before this, untuk menghasilkan primary alcohol, the first reagent here must be what? Must be methanol. Macam mana you nak lukis methanol tersebut? Lukislah macam ni. This is methanol, okay? Meth maksudnya ada satu je carbon. Methanol aldehyde kan? So that means C double bond OH. So dia ada satu je H kat sebelah sini, okay? So again, kalau if this is your Grignard reagent, if let's say you tak tahu macam mana dia nak form this kind of product kan, if this is your Grignard reagent, you identify the alkyl group at your Grignard reagent. Because why? Because this alkyl group dia akan bercantum dengan hydrolyzed methanol. Okay, dia akan bercantum dengan hydrolyzed methanol. So this is the product yang you akan dapat, primary alcohol, where this alkyl group you dapat daripada Grignard reagent. CH2OH ni you dapat dari mana? You dapat daripada hydrolyzed methanol. Okay? Next, macam mana you nak form secondary alcohol daripada Grignard reagent? Okay, you boleh form secondary alcohol daripada Grignard reagent if let's say the first reagent ialah aldehyde accept methanol, and the second one you kena buat hydrolysis. Actually you boleh je ubah kedudukan, sama ada you nak letak Grignard reagent kat sini, aldehyde kat atas ke, Grignard reagent aldehyde kat bawah atau Grignard reagent kat atas. Tapi is either tu lah, tapi yang kedua, proses yang kedua ni must be hydrolysis. Kena wajib macam tu. Okay, ni cara panjang dia lah. Cara panjang aldehyde campuran Grignard reagent in dry ether akan form organometallic. Lepas tu further hydrolysis dapat secondary alcohol. Ni cara yang singkat. Kalau you nak buat cara yang singkat, that's why lah wajib letak 1, 2. Okay, for example, if you have this kind of Grignard reagent and this is your aldehyde yang bukan methanol. So kalau let's say you buat further hydrolysis, you know that you will get you punya product ialah secondary alcohol. Kan? So this is secondary alcohol yang terhasil. So how? Okay, you tengok kat Grignard reagent again, konsep dia lebih kurang sama je. Grignard reagent ni you kenal pasti alkyl group yang directly attached kepada Mg halogen Br. Lepas tu, this is the aldehyde. Okay. Aldehyde ni, bila dia hydrolyze, dia akan affect the C double bond O. So, daripada C double bond O, dia hydrolyze terus dapat COH. Okay. Yang ni, daripada C double bond O, bila dia hydrolyze, terus dapat COH. Okay, so how can you get this product? You get this product bila alkyl group from your Grignard reagent, okay, bercantum dengan carbon. Carbon dia terus bercantum directly pada carbon ni tau. Carbon yang ada double bond O. Okay, so terus directly campurkan dengan carbon yang ada double bond O, tapi because dia buat hydrolysis, terus ada dapat COH. Okay, and the rest you just salin je. Okay, contohnya macam ni lah. I would like to susun dia macam ni actually, so that I can build dia punya jawapan tu easily. Okay, for example, this is the Grignard reagent. Okay, and this is the bond yang I nak sambungkan dengan hydrolyzed aldehyde. Kejap, tebal sangat pula. Bond yang I nak sambung dengan hydrolyzed aldehyde. Lepas tu, this aldehyde, I akan susun dia dalam bentuk T. Macam mana bentuk T tu? Dalam bentuk macam ni. C, and then double bond O, and then H. Lepas tu, ataupun double bond O ni kat bawah lah. C double bond O, H, lepas tu CH2, CH3. I akan susun dia dalam bentuk T supaya I boleh directly attach pada alkyl group dekat Grignard reagent ni. And then since that this is hydrolyzed, so you tak boleh lah letak C double bond O as product. So you kena tukar lah jadi COH. Okay. So that is the trick ataupun tips untuk you mudah nak cantumkan hydrolyzed carbonyl dengan this alkyl of the Grignard reagent supaya you dapat alcohol. Okay, next. What could be the possible Grignard reagent ataupun aldehyde for this product? Okay. So this is again a secondary alcohol. How do you know that it's a secondary alcohol? Because actually this carbon, okay, this carbon is a secondary carbon. Carbon yang directly attached pada OH ni ialah secondary carbon. Therefore, it will make this a secondary alcohol molecule. Okay, so if let's say you ada Grignard reagent dia macam ni, what could be the possible aldehyde for this? Okay, so yang ni I buat macam ni lah, Grignard reagent yang pertama aldehyde, bawah ni kena buat hydrolysis. Okay, so therefore, kalau let's say this is the Grignard reagent, okay, kita highlightkan lah the alkyl group for this Grignard reagent. So this cyclopentane actually belongs to the alkyl group of the Grignard reagent. Therefore, this is your possible aldehyde. Okay, this is your possible aldehyde. So how? Macam mana rupa dia? Okay, kalau let's say sebelum kita hydrolyzekan OH ni, mestilah dia double bond O. So, therefore, this is your possible aldehyde yang menghasilkan this secondary alcohol. Okay, which C, double bond O, H, CH2, CH3. Ni side product ni tak penting pun, tapi just for you to know, that's all. Last one, how can you get tertiary alcohol from the Grignard reagent? You kena guna reagent, ketone, first ketone, second hydrolysis. Ni dalam panjang lah. Kalau ketone campurkan dengan Grignard reagent in dry ether, I will get organometallic compound. Lepas tu further hydrolysis baru dapat tertiary alcohol. But then kalau nak guna jalan singkat, yes, you still can do it. Sama ada yang ni lah kedudukan ni. I nak tukar letak kat sini Grignard reagent ke, atas ni ketone ke, or vice versa, tak kisahlah. Tapi the first one mesti is either ketone or Grignard reagent. Yang second one mesti wajib buat hydrolysis. So nanti kamu akan dapatlah tertiary alcohol. Kiranya kalau Grignard reagent campurkan dengan ketone and then buat further hydrolysis akan dapat tertiary alcohol kan. So macam mana tertiary alcohol tu looks like? Again, in your Grignard reagent, you identify the alkyl group. Okay, so this is the alkyl group in your Grignard reagent. And then next, this is ketone. Ketone kalau buat further hydrolysis akan dapat OH. So, this ketone further hydrolysis jadinya double bond O tu nanti akan jadi OH. So, what could be your possible tertiary alcohol looks like? So, kita cuba buat kat bawah ni lah. Sebelum nak teka jawapan. Okay, so it will be CH3, CH2. Lepas tu, dia akan buat bond directly pada carbon yang ada double bond O ni. Okay. So, kalau let's say after hydrolysis, mestilah double bond O ni terus jadi OH. Okay. Lepas tu, just salin the rest of this je. And then CH3. Lepas tu CH2, CH3. Okay. So despite you got it from hydrolysis ketone, despite you got it from the alkyl group of Grignard reagent, and this is the answer. Betul kan? Sama kan? So this is a tertiary alcohol because this carbon yang directly bonded pada OH is a tertiary carbon. Therefore, it will make this molecule a tertiary alcohol. Okay, and this is the side product yang terhasil. Okay, next. Okay, if this is the tertiary alcohol yang terhasil daripada Grignard reagent dengan ketone, so what could be the possible ketone looks like if let's say this is the Grignard reagent and this is the product yang terhasil? Okay, so sekarang ni kita tengok kalau let's say Grignard reagent dia bagi this alkyl group. Okay, so you bulatkan alkyl group at your Grignard reagent. Therefore, this CH3 is actually comes from the alkyl group at the Grignard reagent. Okay, and what about this? This could be the possible structure of your ketone actually. This could be the possible structure of the ketone yang menghasilkan this tertiary alcohol. So, macam mana ketone tu looks like? Okay, ketone tu looks like this. Alright. Sebenarnya CH3 campurkan dengan this ketone. Tapi sebab dia hydrolysekan this ketone, dapatlah OH. Kiranya this part belongs to the ketone. And this is a side product yang terhasil. Okay, the last one, how can you form carboxylic acid from the Grignard reagent? You boleh form carboxylic acid from Grignard reagent if you use the first reagent, carbon dioxide, and then you buat further hydrolysis for the second process, and you will get carboxylic acid. Okay, ni cara panjang dia lah. Kalau carbon dioxide plus Grignard reagent and dry ether, you will get an organometallic compound, and then further hydrolysis teruslah OMGX ni jadi OH. And this one pula, Grignard reagent dia react dengan the first one, dia react dengan carbon dioxide, second one dia buat hydrolysis, and then apa yang berlaku kat sini, MgX ni terus kita replacekan dia dengan C double bond O OH. Alright guys, so if let's say you ada this kind of Grignard reagent, dia react dengan carbon dioxide and further hydrolysis. Okay, carbon dioxide bila dia further hydrolyze, dia akan menghasilkan C double bond O OH. Kiranya one of the double bond saja yang hydrolyze jadi OH. Okay, that's why kamu akan form carboxylic acid. Macam mana kamu form carboxylic acid? Okay, you look at your Grignard reagent, you kenal pasti the alkyl group at your Grignard reagent, which is this is the alkyl group at your Grignard reagent. Apa yang berlaku? The carbon that is directly attached to the Mg halogen Br akan terus melekat dengan hydrolyzed carbon dioxide, which is C double bond O OH. Okay. Okay. Next, if let's say you have this carboxylic acid compound, and then previously dia ada react dengan carbon dioxide dengan further hydrolysis. What is the possible Grignard reagent yang menghasilkan this carboxylic acid? Okay, again, if you look at this compound, you kenal pasti which one yang alkyl group attached directly pada COOH. So, this is it, the alkyl compound ataupun alkyl group yang directly attached pada COOH. That means, this carbon atom previously, dia directly attached pada Mg Mg halogen, MgX. So, this is the halogen yang digunakan ialah Cl. Therefore, this is the possible Grignard reagent yang menghasilkan this carboxylic acid. Okay? Because, previously this alkyl group directly attached pada Mg halogen Cl. Okay? So, next, if let's say you have this kind of Grignard reagent, what is your possible carboxylic acid looks like? Okay, in this case, I want you to highlight the alkyl group yang present in this Grignard reagent, which this is the alkyl group yang present in the Grignard reagent. Apa yang berlaku? Dia akan directly attach pada hydrolyzed carbon dioxide, which is COOH. Macam tu je, as simple as that. Okay, and dia punya side product dia is MgOHCl. Alright, so I think that's all. That's pretty much it for everything about haloalkane. So thank you guys for listening.